Hello, guys. How are you all? I hope you are all good. So, in the last class, we have discussed about the concepts related to modulus and its property, conjugate the and its properties, and then how we show a complex number in an argand plane. Okay, we have discussed all these things. So, today in this class, we are going to discuss exercise 2.3, and I hope you will be able to do the plotting of the points on argand planes, right? So today we'll start from question number 2. Okay, we need to find the modulus, okay, of the following given numbers. So let's try to do question number 2. So exercise 2.3, question number 2. Let's try to do number A. 4 minus 3i. So let's say this is z. Okay, let z. Let- so let z equal to 3 minus, no, 4 minus 3i. We need to find modulus of z. So therefore modulus of z equal to modulus of 4 minus 3i, right? And then what is the formula? It is root over, right, x square minus y square. Oh, it is plus, not minus. So 4 square is how much? 16 plus 9. This is how much? 25. It is 5. So here we are doing modulus. That means only the positive one we will consider. Okay. So this becomes our number A. And then I think you will be able to do number B. Right. Let's try to do number C. Okay, what is that? So let z equal to 3 plus 4i, 5 plus 12i. So now if you need to find the modulus of z, then so modulus we can write separately. We can break down the modulus, right? You remember the property d. Then now it became a separate entity. Then you can find out 3 square plus 4 square. Here also 5 square plus 12 square. Now 3 square is how much? 9 plus 16. 5 square is how much? 25 plus 12 square is 144. So this will be your 25 and this is your 169. This is your 5, this is your 13, and 5 into 13 is 65. This is your number C. Then let's D. Will you be able to do? Okay, I will show you number D. I will show you number D. Oh, see here, this is minus 3D. Here will become minus 3 square. Number D is what? Let z equal to 3 plus 4i, then 5 plus 12i. So therefore, modulus of z equal to, it will be modulus of 3 plus 4i, 5 plus 12i. Then same as multiplication, you can break down the division also. And now it is easy, right? Then use the formula root over 3 square plus 4 square root over 5 square plus 12 square. Hey, this is same. Huh? This is same. 9 plus 16. And this is your 25 plus 144. So this is your 25. This is your 169. So 5 and then 13. This is your answer. Okay. And then I hope you will be able to do. Can you really be able to do number E? The rest will be your homework. Okay. I will show you number E. 1 plus I minus 2 plus 1 plus I to the power minus 2. Let z equal to 1 minus I to the power minus 2 plus 1 plus I to the power minus 2. So therefore, z equal to should become, oh no, let's break them first. It will be first, the minus 1 we will make it into no minus exponent, the inverse. It will be 1 by 1 minus I square plus 1 by 1 plus I square. Then now a plus b whole square formula, 1 square minus 2i plus I square, 1 square plus 2i plus I square, 1 minus 2i, this become minus 1 plus 2i, this become minus 1. So plus and minus cancel out, and you already got how much? Minus 2i plus 1 by 2i. And this is minus 2i, this is plus 2i, right? It becomes 0. And this is what? 0 plus I dot 0. And a plus ib form. So your modulus will be 0. 0 square plus 0 square. Hey, this is your answer. This is your number 2. 3, 4 you will be able to do, whether they are collinear or not. So you plot on the plane, okay, diagram, and you see if they become a straight line or not. All these 3 points, they become one straight line or not. And then in number B, so that this represent passes through the origin. So whether it passes through the origin or not, you check in a diagram. If it passes, then you write down these 3 points, okay, passes through the origin. You write it down. Then we'll proceed to the next question. So what have I done? Okay, see, by using a done diagram so that these points are collinear. Okay, same whether they're straight line or not. We'll proceed to question number 5. So what is there in question number 5? If z equal to x plus iy, and this is equal to 1. Okay, z is given x plus iy, and the z minus 5i and z plus 5i, their modulus is equal to 1. So we need to prove that y equal to 0. Okay, let's try to do. Let's write down given. Okay, x z equal to x plus iy. Okay, and what do we have? Z minus 5i, z plus 5i. Okay, this is equal to 1. So this one you can break it down, z minus 5i and then z plus 5i equal to 1. Then what do we have? Z minus 5i, we want to transfer to this side, it multiplied z plus 5i. Now you put down the value of z. Okay, what is z? X plus iy. So x plus iy minus 5i, x plus iy plus 5i. Then now you can take I common. Okay, the imaginary part you can write them together now. X, if you take I common I, then you will get y minus 5. Yes, here also if you take I common, then it become y plus 5. Then now you use that one below modulus formula. This is x, this is your y, this is your x, this is your y. Okay, where is I? So it is x square plus y square d. And here also it is x square plus y plus 5 whole square. Now you can remove both sides are square root d. You can remove, get x square y minus 5 square x square y plus 5 whole square. X and x you can cancel, they come 0. Then you have got only y minus 5 whole square, then y plus 5 whole square. Again both are whole square, you can remove taking square root, then you will get y minus 5 and here you will get y plus 5. Is it okay? Now if you take minus 5 to the other side, then what you will get? Oh, both the y will become 0. And minus 5 is equal to, no, we cannot do this one. Wait, this is against our law, mathematical law. We need to break down the square root. Okay, so it will become y square minus 2 into 5, 10y plus 5 square. 5 square is how much? So y square plus 10y plus 5 square. Then what do we have? Y square, the 5 square, 5 square. Then you have got minus 10, and this is your plus 10. So if you bring this side, it will become minus 10y equal to 0. So you will get minus 20y equal to 0. Now it makes sense. 0 by 20. Then this is 20. Then so y equal to 0. Fine. Why we cannot take the square root here? You have got the answer. The variable got cancelled out. Okay, now what is 6? What is given? Z equal to x plus iy. And then what do we have? 2z plus 1 modulus z plus 2. Okay. Then to show that x square plus y square equal to 1. Okay, now we will take the help of this one. 2z plus 1 equal to z plus 2. Now put the value of z, x plus iy. And here also x plus iy. Now, okay, 2x plus 2iy plus 1. Here x plus 2 plus iy, and you can write down 2x plus 1 plus, this is your real part, this is your real part, I 2y you can write down the x plus 2 plus iy. So use the formula now. 2x plus 1 whole square plus 2y whole square. And this side also x plus 2 whole square plus y square. Now square both sides, then the square root will go away, and then we will have how many? 2x plus 1 whole square. Let's break it down here. D. So it will be 2x square. Let's 2x square is how much? 4x square plus 2 into 2x into 1. It will be 4x plus 1 square is 1 plus 2y square is 4y square. Here also x square plus 2x plus 4 plus y square. Then x square plus 1d equal to 1 we need to show. So what do we have? This is 4, you transfer that side. All the x and y you write on one side. 4x square we will arrange. If you bring this side, then you will get minus x square. Then you also got 4x. You bring this side, you will get. Okay. This one is how? Here we have got 2. 2 into 2 is 4x. Oh, it become cancel out. So no need to write. So this become your 4x. So this one and this one becomes 0. And 4y square you have minus y square. There you have 1 plus 1 it go become minus 1. So now this is your 3x square plus 3y square to 3. Okay, now you divide all side by 3, you will get x square plus y square equal to 1. Okay, you can write here dividing both sides by 3. Here you write down squaring both sides. And dividing both sides by 3. So therefore so in this way, okay, will you be able to do number B? Number B will be your, okay, you try it by yourself. Okay, so B, you try it by yourself. Then now we'll do 7. What is in 7? What is given? If conjugate of z equal to minus z. Okay. And where z is not equal to 0, then we need to show that z is a purely imaginary number. That means there is no real number. Okay. There is no real number, only I will be there. Let's see, given. We have z. We don't know z. So let's take z equal to x plus iy or a plus ib you can take. So conjugate of z will be x minus iy. Then if z bar t, so according to equation, what do we have? Z bar equal to minus z. So what is z conjugate? X minus iy. And what is minus z? It will be so x minus iy minus x minus iy. So if you bring this side, you will get what? 2x or x plus x. Okay, let's write on one more step. It become plus I, you transfer to the other side, this become plus iy, and this is your minus iy. So 2x equal to iy minus iy is 0, so x is equal to 0. So there is no real number. Since x is 0, we have got only iy, which is, so therefore you write down z is equal to 0 plus iy. Hence z is a purely imaginary numbers. Fine. This is our question number 7. Very short day. What is 8? We have got z1 is equal to this much. z1, z2, modulus of z1 equal to z2 equal to 1. And then we need to prove that z1 plus z2 equal to 1 plus z1 plus 1 by 1 plus z2. Okay, what is the hint given? So their square also will give us 1, and then square of modulus is z1 and z2 conjugate. They learn from there we will get 1 by z1 equal to z1 conjugate. Again 1 by z2 will be z2 conjugate. Okay, then from the right hand side we have got 1 by z1, 1 by z2, and then 1 by z1 is nothing but z1 conjugate, and then z2 conjugate. And then from that, what to say, from the property we can write it down, z1 plus z2 conjugate, and then modulus of their modulus is equal. Okay, very short. Okay, let's do number 8. A is given z1 conjugate, or not conjugate, modulus z2 modulus equal to 1. To prove that, one by z1, 1 by z2. Okay. z1 equal to z2 equal to 1. So therefore we can write down their square, right, is also equal to 1. Now z1 square equal to 1, and z1 square is nothing but your modulus of z1 multiplied its conjugate equal to 1. So what do we need? On the right hand side, what do we have? 1 by z1. So z1 conjugate is 1 by z1. Similarly, is equal to 1. So this is also z2 into z2 conjugate equal to 1. So Z2 conjugate will be 1 by Z2. Okay, 1 by Z2. The now left hand side, right hand side you write down RHS modulus of right hand side equal D plus 1 by Z2. So 1 by Z1 is nothing but your Z1 conjugate. 1 by Z2 is nothing but your Z2 conjugate. Then you can write it down, this one whole conjugate, and then by property you can write down their modulus is equal to Z1 plus Z2. They in modulus it is same. So you can write down since okay. 1 minute. Hmm. Hmm. So therefore LHS with this is nothing but your LHS. Therefore LHS equal to RHS, hence modulus is equal to in the question there is no conjugate D. You make correction, okay? In the hint there is conjugate. So they forgot to put the conjugate mark. There will be conjugate. Okay, this is your question number 8A. Now let's proceed to number B. So what is the number B? 8B. Oh, it's too big. Z1 modulus of Z1 equal to modulus of Z2 up to Zn is 1. Then we need to prove that 1 by Z. It is same. Like as question number A. This is same. 1 by Z1. I think you try number B. If you can't, then I will help you. Okay. Just you need to do the extension. So in the first one we have done only up to 2. In the second one you do dot 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 dot, you extend it up to Zn, then you will get the answer. You try. Okay, then if you can't, then I will prepare a video for you. Then next, what do we have? For many complex number z, okay, so that the minimum value of z plus z minus 1 is 1. So that the minimum value of z plus z minus 1 is 1. 1 से मिनिमम 1 से कम नहीं हो सकता क्लियरली. Do you remember that property? Where did we got that one? One is greater and one is not greater. The modulus of the sum of two complex numbers can never be greater than the sum of their moduli. We can apply this one. The minimum value of z plus z minus 1. That means separately, okay, z1 plus z1, it cannot be greater than this one, z1 plus z2, the sum. इससे बड़ा नहीं हो सकता. That means 1 से बड़ा नहीं हो सकता. Let's try. 9 ladi. This is your 8a. So this is your 9. Z minus 1 sum बोलते हैं z plus z. It will become 2z and we will get only minus 1. Okay, we'll do one trick. Since it is given modulus, so this one pillar z minus modulus of z minus 1, okay, we can write as 1 minus z. So the sum, okay, this one is given in equation, so this one can be written as 1 minus z. Since it is modulus, okay, we can write, you can interchange its place. Then pillar since, okay, not z only, since z plus 1 minus z, alright, greater than equal to pillar the sum of the modulus z plus z, z plus z करेगा, z plus 1 minus z. So it is greater than equal to z, z cancel, then you will get modulus of 1, and modulus of 1 is nothing but 1. That means the sum of these two is greater than equal to 1. That means the minimum is 1, 1 से बड़ा हो सकता है. So write down hence below above, hence the minimum value of z plus z minus 1 is 1. Number 10. This is such that z minus 1 is purely imaginary. Oh, like number 7. Number 10 is like number 7. Then show that modulus of z is equal to 1, or x square plus y square equal to 1. X square y square t, then x iy you have to take. Okay, let's do number 10. What is the number 10 pillar? So let's take out, let z equal to x plus iy. Then what do we have? Z minus 1, right? And then we have got z plus 1. So it can be written as x plus iy minus 1, x plus iy plus 1. Then you can write down the real and imaginary part separately. Fine. Then x plus 1 plus iy, x minus I plus iy. I think we can take conjugate d. This is another, or this is not I. We are taking the conjugate in order to remove the I, the imaginary number d. So this will become x plus 1 minus iy. Here we will got x minus 1 plus iy, and then x plus 1 minus iy. Then now this become, okay, better to give this one d, so that, okay, we can take, there will be no confusion. Here also you can do that one. Now this is your a, this is your b, this is your a, this is your b, d. So a square plus a square minus b square, and then we have got I square, so it become minus minus plus y square. Okay, then this is your x minus 1, this is your x plus 1. You need to multiply now d, there is no other way. Okay, this one and this one, again you multiply x minus 1, then iy. Then what do we have? Plus iy x plus 1, then we have got minus I square become plus I square become the will y square. Fine. Then break down a plus b whole square. जरूरत नहीं है, we have already got the real number. This is your x square minus 1 square minus ixy plus iy plus iy, right? Plus iy, this is your x plus iyxy d plus iy plus y square. Ixy and ixy cancel out. Then you have got x square plus y square minus 1. This is your real part. And here you will got plus 2iy. And then below x plus 1 plus y square. Then what we need to find? We need to solve purely imaginary day. Purely imaginary. So let's break it down into a plus ib form. So, okay, what do we will get? X plus y square minus 1 x square plus y square minus 1, below we will get x plus 1 whole square plus y square plus 2iy, right? So I 2iy x square plus 1 square plus y square. Then z minus 1 and z plus 1 is purely imaginary. That means this is purely imaginary. That means this is 0, right? In given it is said that z minus 1 and z plus 1 is a purely imaginary number. Right? We need to show that z modulus of z is 1. So if this is purely imaginary, then this portion, okay, the real part becomes 0. So therefore the real part of z minus 1, where is z plus 1? Okay, this is 0. So this implies x square plus y square minus 1, x plus 1 whole square plus y square equal to 0. Then this portion, okay, it goes aside and it becomes 0. Then what do we have? X square plus y square minus 1 equal to 0. Right? So 1 you transfer other side. X square plus y square is how much? 1. Proof हो गया x square plus y square equal to 1. And x square plus y square is nothing but below. If you take the square root, then here also square root of 1, and then this is nothing but your below modulus. Yes, this is nothing but your modulus of z, and this is root over 1 is how much? 1. हो गया ना? Z modulus of z equal to 1. So you can write down, therefore modulus of z equal to 1, or x square plus y square equal to 1. And so question number 11 will be your homework. Given z1 and z2, then you need to prove the left hand side and right hand side. Okay, 1 2 3 4. Then question number 12, this is also, first you try. Okay, for any complex number z, if z plus 1 equal to z minus 1, then so that the real part is 0. So we have already, इसका उल्टा होगा, the real part is 0. That means that is z plus 1 and z minus 1, their modulus, okay, is 1. You can write down. Okay, you try, and if you are not able to do, then I will prepare one more video, okay, regarding 8b, then 12, 11 you will be able to do. Okay, so after this much, then first you try by yourself. Okay, thank you everyone. Let's meet you in the next class. Bye bye.